So we're still solving systems of equations. You'll notice here we're solving systems of equations. Now we're going to use a method though called elimination. Okay. Now elimination has got a couple of different ways that we use it. Today we're going to be looking at addition and subtraction. The next method is using multiplication, but elimination simply means that we're going to eliminate a variable. Okay, so with two equations and two variables, before we can know what one of them is, right, we have to eliminate one. And so that's what this method does. By using addition or subtraction, we're going to eliminate a variable. Okay, so three quick steps. These all come from your book. So you can write them down now. You can grab them from your book. But let me go ahead and toss an example up here. And then I'll talk through these three steps while we're looking at the example. So step one is that we've got to make sure the system is written so that like terms are lined up. Okay, like terms have to be lined up. So you'll notice we have x's and y's are lined up. You can see that we have the equal signs and the constants are lined up. So that's the first step. If it doesn't already look like this, then it needs to look like this. Okay, this is not substitution where I'm trying to get y by itself or x by itself. The elimination method, first and foremost, requires that all these pieces are lined up so that we can take the next step. And the next step is that we want to be able to add or subtract the equation, and we'll figure out which one in just a minute. But what we're trying to do here is eliminate one of the variables. Okay, so notice down here we've got a plus 6y and a minus 6y. And so if we add those two terms together, the y's would disappear. And that's what we're trying to do. We're trying to eliminate a variable. Now, what's left over is going to be an equation that has just one variable. So when we eliminate the y's right here, we're going to be left with an equation that only has x's. X equals something. All right. So we can solve for x. And then once we know what x is, then we can substitute that value into one of the equations to solve for the other one, right? Because our answer is always going to be, if we have one, an ordered pair, an x and a y. So either we know what x is and we substitute for y, or we know what y is and we substitute for x. So let's take this example now and actually do this example using elimination. And you'll notice we begin here, x's, y's, equal sign, constant. Everything is lined up, right? And that's step one. Like everything has to be lined up. So here we go. Notice your y's here. Your y's have the same coefficient but with opposite signs, right? So plus 6, minus 6. By adding these two equations together, the y gets eliminated. So 4 plus 3 is 7x's, plus 6 minus 6, 0 y's. So those get eliminated. 32 plus 3 is 35. And so here's our equation, 7x equals 5, which is a simple equation to solve. Divide both sides by 7, x equals 5. And that's part of our ordered pair. Step 2 was now, or rather, this is all the way down to step 3. Step 3 is let's take x equals 5, plug it back into either of those equations to figure out what our y value is. Doesn't matter which one, you just pick one. We'll go with the top one. So 4 times x equals 5 plus 6y equals 32. Okay, so here we go. Let's solve this. 4 times 5 is 20. That has to be subtracted from both sides. Divide both sides by 6. Y equals 2. And that's the other part of our ordered pair, 5, 2. So if we were to substitute the ordered pair 5, 2 into these two equations, then they should be true statements. 5, 2 is the solution to the system because it works for both of them. Now, you're wondering, what if I pick the other one? Well, let's do that one time just so you can see what happens. So using the second equation, 3 times x equals 5 minus 6y equals 3. Okay. So 3 times 5, that's 15. Subtracted from both sides gives me negative 12. Divide both sides by negative 6. And y still equals positive 2. And that might be something you do to check. Graphing is still an option. Substituting to make sure that that coordinate pair works in that system is an option. But there really is no reason to miss these because we can go back and check. So let's do one more like this. And you'll notice again, x's are lined up, y's equal constant. So everything is lined up like it needs to be. If it wasn't, we would move some stuff around. Okay, now in this case, you'll notice that the x's have similar coefficients, except they're the same, right? They're not opposites, they're the same. So in this case, to get the x to disappear, to get the variable to disappear, we have to subtract the two equations. So 2 minus 2, that's 0x, so the x has been eliminated. And since we subtracted there, we have to subtract everywhere else. So 5 minus 9 is negative 4y. 6 minus 22 is negative 16. And so that means that y equals 4. And that's part of our solution. Okay. Step 3, take it and plug it back into one or both of those two original equations to find out what x is. So 2x plus 5 times y, which is 4, has to equal 6. So then 2x equals, so this is 20 subtracted from both sides is negative 14. So x equals negative 7. And there's our solution, negative 7 and 4. Again, this can be checked in both equations. It could be graphed. It could be a number of ways that we could check this. But there we go. Now, let me give you one to try. And you have to decide if it's going to be addition or subtraction. But this one is yours. Okay, so we added these two equations together because the plus 4 and the minus 4, to get to eliminate the x, we add these two equations. Minus 4 plus 4, 0x, that went away. So now we have to add everything else. So plus 3 and plus a minus 5, that's minus 2y equals 2. So y equals negative 1. We're going to take that y equals negative 1 and plug it back into either one of these two equations to solve. I'm going to use the top one. Okay, so negative 4x equals, so this is going to be negative 3 added to both sides, gives me 0. Okay, so x equals 0. Easy enough. All right. And again, this is something we could go back and check, and should go back and check, okay, if you're doing these on your own. Now let me give you, I think, maybe one more of these, and you figure out addition, subtraction, you figure out how to solve, and then solve it. So step 1, I hope you noticed the x's and the y's are not lined up. So the first thing you've got to do, and you'll have to do this on occasion, but the first thing we need to do is we need to rewrite this system of equations so that the x, y's, equals, constants, all that stuff is lined up. Okay, so here we go. Now, doesn't matter if you put the x first or the y first, it just has to be lined up. We've done enough of standard form in the past that it feels better to have the x first. Doesn't really matter. As long as you have the x's, y's, equal, constant, as long as everything's lined up, you should be fine. Now, what did you do? Did you subtract? Did you add? This particular system of equations could have gone either way. If you notice the x's, they have the same number. So if we had subtracted the equations, the x would have been eliminated. The y's have opposite coefficients, and so if we added those, then the y would have disappeared. You're going to get the same answer. It just depends on how you want to solve it. I prefer to add when I can, and so that's what I'm going to do, is I'm going to add. If I can, yeah. So Ooh, changing my color. All right, so I'm going to add. I prefer to add when I can. So 3 plus 3 is 6x plus 4 minus 4. Y gets eliminated. And then we have 36 on the other side. Solving for x. X equals 6. Either one of the equations will work. 4y plus 3 times 6 equals 22, which means that 4y equals 4 and y equals 1. So my ordered pair is 6, 1. Okay. Now, I don't want us to forget the fact that, again, there are special cases that we have to watch out for. And we didn't run into any of those doing addition and subtraction examples, but there are those no solution, infinite solution type scenarios that can happen that we have to be on the lookout for.